again, my name is Victor Gomes. I'm an extension agronomist here at the Dickinson REC. I'm a relatively fresh face here. I've only been with the team for about 1 year and a half. And I'm just going to talk very briefly about some of the trials I have going on this year. I'm definitely not the star of the show, so I want you to have more time with the other speakers. So I'll be very brief. So one of the trials that I have going on this year, you're seeing right in front of you here, we're looking at boron fertilization in canola. Now, many people would claim, and colleagues including, that North Dakota's soils are fertile enough that you don't need to worry about micronutrients. Now, while that may be true, we don't have enough data to back that affirmation, so we need to conduct research to see how these plants respond to these nutrients, especially here in the West. So this trial is being conducted here in Dickinson, also in Minot. Now, why is boron important for canola? So boron is involved with several processes during the reproductive development of the canola crop that can have a direct impact on yield. Specifically, bud formation and pollen size and development are impacted by boron. Now, canola plants, because boron is not mobile within the plant, they need a constant supply of that nutrient during the season. And there are several factors that can impair boron uptake in canola, namely dry soils that tend to be the norm here during the grain filling stages and flowering. Luckily, this was not the case this year. We've been getting some really nice rains, but also soil pH. Be it very low pH or very high pH can impair boron uptake by the plants. This soil where this trial was put down had a pH of 5.5. So hopefully we'll be able to capture the effects of that. So in this trial, we're looking at different products, different sources of boron, as well as different rates applied at different times. So we have granular boron, we have foliar boron. The granular is applied at planting, and the foliar is applied at 10 to 20% bloom. And we also have treatments that combine both sources applied, both granular and foliar. We don't have results from this trial yet. This is the first year I put it. I did get plant stands, and there was no difference, and I didn't expect to have any differences there because boron is more so involved with the reproductive stage of canola. Another trial that was kind of a priority, before I go there, this trial is sponsored by the Northern Canola Growers Association, so I appreciate their support. The next trial I'm going to talk about looks at soybean inoculation. Because soybean is a relatively new crop here in western North Dakota, we don't have very solid recommendations for inoculation in soybeans. And as we know, inoculation and nitrogen fixation through inoculation makes up for a big part of the nitrogen that is used by the crop. So we have a trial sponsored by the North Dakota Soybean Council. It's going on here in Hettinger, in Williston, and Minot. And we're looking at different products, different inoculants, different rates, and also looking at a starter fertilizer. Now, that's also a newer trial, so I don't have results for that just yet. One thing that I did is I went out there with a chlorophyll meter at V4, and I measured the chlorophyll content of the leaves of the plants in each plot. And usually you can associate chlorophyll with nitrogen content in the leaf. So a very preliminary result, take it with a grain of salt. The plants that had the highest or the greatest chlorophyll content in the leaves were those that received not only a standard rate of the inoculant, but also 20 pounds per acre of nitrogen, be it granular or liquid inoculant. And that was a soybean virgin soil, so there was never soybean being grown there. So when we applied the standard one-time inoculant, according to the recommendations of the manufacturer, plus 20 pounds of N, we seem to have the highest content on the leaf at that stage. I'm going to measure that again now that it's on the reproductive stage, and we're going to see how that impacts the yield. Now, a more personal project kind of that was brought to us via our advisory board is looking at novel crops, underused crops. So I'm going to show them to you, see if you recognize them. Does anyone know this plant? So this is quinoa. last year I got in touch with a few guys that are growing it here and a company that's contracting with those people. And we had about 3,000 acres planted with this crop here in North Dakota. It's mostly being sold to Canada. And apparently at a pretty good price. However, they're getting recommendations coming from Washington State and Idaho State. So we don't have local data to support it here. So that's the only thing I'm trying to understand better. We have a couple of demonstration plots over there. The one thing I've got to say is that there's not too many herbicides that you can use for it. So they've been hammered by weeds pretty bad. We did have a burn down application, but after that, nothing. So they have a hard time competing. Now, the second crop I'm going to show you is a close relative to that first crop. So this is grain amaranth. So it's a close relative of redwood pigweed and the others, but this is a domesticated kind. It's been domesticated by ancient South American communities. But something in common for these two crops is that they are really high protein content. They're very precocious, and about 90 days you can go from seed to maturity. And they have a high potential to be used as a forage or as a grain crop. Now, for quinoa, we have a market well established, not as much for amaranth. So at the end of the season, we're gonna collect a few plants and look at the forage quality of these species. For quinoa is about the same size as canola. Amaranth is even smaller. So the quinoa was seeded at about 11 pounds per acre. Amaranth 2 pounds per acre, and they could have grown much more if not for how weedy it is out there. They really accumulate a lot of biomass. They can get as tall as 7 feet tall. They produce a terminal inflorescence, looks a lot like sorghum. When we go back there, and we're going to also collect soil samples from each plot to see what the nitrogen content is there. Yeah, I know that talking with some people, I've heard that pursuit works pretty well with it. It's not labeled, but yeah, we need to work with the EPA to get these, at least an emergency permission. It's not much you can do. And I know that some people are also switching from no-till to conventional tillage system to help manage those weeds. All right, well, thank you very much.